Good afternoon, dear participants of the conference. Today, the authors present the paper called Astronomical Metadata Mining from FITS files by the telescope software. Now, the fast technological progress provokes creation of a big amount of data. There are a lot of different fields of science that use the high-dimensional data sets for analysis. One of them is astronomy. For scientific research and analysis, such a big amount of data should be processed by the special data preprocessing methods and data reduction models, which simplify input for reducing unnecessary information. This means that we also have the data mining problems in astronomy. So I want to tell you about the Kalitek project and developed telescope software, which implements all data mining steps during processing the different types of astronomical information in automated mode. On this slide, you can see the results of frame processing by the Kalitek software. There are raw frames on the left side and processed frames with alignment and centered view on the right side. Also, detected moving objects are present on the right side. On this slide, you can see the very brief sequence of the online processing. Images are saved from telescope, then processed by the Kalitek software in different modes, and we can get necessary results as light curves and appropriate reports. But how to find and process the appropriate raw data? Almost all astronomical frames have a FITS format with standardized file structure and extension. The FITS format was developed by NASA and is accepted as an international astronomical standard. It is used by many astronomical and scientific organizations like International Astronomical Union. The structure of the FITS file consists of a header with metadata and a binary image. An example of the FITS file is presented on this slide. Also, the metadata in a header of the FITS file is presented on this slide. This table includes a list of such fields from the metadata with their description and types, including the system fields. Under the research and scope of the Kalitek project, we have developed the telescope software for mining the big astronomical data from the different storages and archives, parsing the metadata from each astronomical file, and collecting it with the further insertion in the database. Such parsed data were used for the different purposes of astronomical image processing and even machine vision. The telescope software realizes the different data mining tasks like receiving, storing, selecting, preprocessing, transforming, useful data extraction, classification, and knowledge discovery in databases. The telescope software implements the following algorithm for astronomical metadata mining. And the representation of such an algorithm in view of the UML diagram is presented on this slide. In the next slides, you can see some examples of pages and windows with the graphical user interface of the telescope software, like work folder configuration window, search parse page, find to, and converter pages. And show more window with astronomical metadata after searching and parsing. The following stack of technologies were used for the software development: C# programming language, .NET platform, Windows Form technology, and MDB database file for Microsoft Access database management system. In this slide, you can see an example of the fill it in with the astronomical metadata FITS table in Microsoft Access. Regarding the main processing algorithms developed under the Kalitek project and related software like Telescope, you can find the detailed information in a few important publications in the journals with impact factor 5+. The Kalitek project is developed by enthusiasts. Kalitek has assisted in making over 1,600 discoveries of asteroids, including 5 NEO, 21 Trojan asteroids of Jupiter, 1 Centaur. It has been used in about 700,000 observations, during which 5 comets were discovered. The telescope software was developed during research under the Kaleidec project. It was tested with up to 1 million astronomical files from several archives on the different observatories in the world. Such archives include astronomical files of different formats and types of metadata. All such metadata was parsed and structured, which gave us an opportunity to perform the proper metadata mining and further image processing, machine vision, pattern recognitions, etc. So, thank you for your attention.